Hello everyone. Can I get a quick show of hands who here would consider themselves to be outgoing or an extrovert? Thank you. And who here sees themselves as maybe not shy, but laid back or relaxed? Yeah, me too. And lastly, is anyone here an introvert or a little more reserved? So as you can see, even in our audience here, we have a spectrum of behavior. Different people are more or less comfortable in proximity to others. Now, I'd like you to consider somebody with autism. Autistic people have difficulty deciphering social cues. For example, visual cues like facial expressions. They may get too close in a conversation, or they may be too far to engage, or they may laugh at inappropriate times. Today, I'd like to share with you how we can use the fruit fly to better understand these neural disorders. And we do this by studying the neuron in depth. These microscopic cells are like the brain's cables, allowing it to control the rest of the body. They're comprised of complex networks and connections in the brain that allow it to control the body, for example, moving your legs so that we can walk. And what's interesting is that neurons are virtually identical between fly to mouse to human, all the way up to the whale. And it's when these neurons are no longer functioning properly and the brain can't send its signals, this is where we get neuropsychiatric disorders such as autism. The current practice today to treat these disorders are to use drugs to either recover impaired signals or to repress overactive signaling from the brain. The issue arises with these complex networks and connections that the drugs often have widespread unwanted side effects like sleeplessness, nausea, depression, or worse. Clearly, it would be better if the treatment just attacked the issue without creating any more problems. And this is where my research comes in. I'm studying a specific protein that helps to create these connections in the brain, but also helps the brain send its signals. And this protein is important for two reasons. First, like the neurons themselves, it's very similar between flies and humans, allowing us to study it in flies and have impact on us as humans. And second, if there's a mutation or malfunction in this protein, this is where we see people with a predisposition for autism. I intend to map where this protein creates these connections in the brain and where these connections lead to identify a specific molecule or pathway that could be contributing to the symptoms of autism. And doing this can provide a more succinct target for treatment. And if I'm successful, then your daughter or son or anybody who may be affected by this disorder can receive treatment without suffering from other drug-related effects. Thank you.